If you've been watching through this series, you have gone through about 2 hours of theory. It's finally time to get our hands dirty and configure something. These practical skills are critical. All the theory in the world won't benefit you if you can't put it into practice. By the end of this video, you'll be able to take a new Cisco router or switch and apply some basic configuration to it. Cisco devices are quite popular, and that's why we're starting there. Other brands will feel a bit different, but the principles will be the same, so you can take what you learn here and adapt it as you need to. At the end, we'll briefly discuss how you can make your own labs to practice your skills. Are you ready? Let's get started. We'll start by thinking about our devices physically. Routers and switches come in different sizes. Some are small devices that you would find at home or in a SOHO environment. These often bundle a few features into one single device. At a mid-size or large office, you will usually see larger devices. We often use separate routers and switches rather than an all-in-one solution. If you happen to work at a service provider, you will see massive devices like this one. The devices that we use need to suit the network that they're part of. We typically need to think of things like the number of ports we'll need, what performance we'll need, and what features we need. Most of these devices will come with a base license, which means that you're licensed to use their basic features. But, depending on what you need, you may require additional licenses to get advanced features. So let's say that this router here has been sent to us for configuration. First, we would want to know what each part of the router does. These ports are the built-in data interfaces. They have their name written above or below them. GE001, for example. This name means Gigabit Ethernet, Module 0, Port 0. The built-in interfaces are part of Module 0. As this suggests, we can add more modules by removing the panel to the right and installing it, like this one right here. More modules may mean more interfaces. The interfaces themselves come in different forms. You'll see the common RJ45 style port that a regular network cable would connect to. There are also these rectangular ports. These are where the SFP transceivers are connected. We regularly use SFPs to connect fiber optic cables. In the case of this router here, we can choose which type of port we want to use. On the far left, there is a management port. This is a special port used only to manage the device. That is, it's meant to carry traffic that's used for managing the router itself. The management port is optional, as it's not the only way to manage the device. Where it's really handy is when we have a few routers and switches. We can put all their management ports into one single subnet and manage them all from one place. Most Cisco devices have USB ports. We don't use them very often though. They're mostly there for when we want to update the router's firmware or when we want to copy some logs from the router. Right next to the USB ports are two console ports. One is a mini USB and the other uses an RJ45 connector. The console ports are another way of managing the device. Typically we use these to configure the device when it's brand new, but sometimes we may use it in an emergency when no other forms of management are working. We'll get to this shortly when we're ready to start the hands-on configuration. The auxiliary port was used in the old days. You could connect one of the old dial-up modems, so you can still get to the device from a remote location. Apparently, you could even connect an old physical terminal server. I've never actually seen this port in use in my time. If you have, please let me know in the comments. I'd love to know how that worked out for you. And one last thing I'd like to point out is that some devices have one power supply and some have two. Others start with one and are then upgraded to two. This prevents the entire device going down if one power supply fails. And yes, that does happen. You can also use this to connect the device to two different power sources, perhaps two different UPSs or two different power rails. These dual power rails are commonly seen in data centers. they're connected to different generators, so if there's a power outage on one generator, the other one stays up. So now that we know all of that, how do we connect to our router? Well, it's brand new. It doesn't have any IP address to connect to yet, so we need to use the console port to apply our initial configuration. We may also use the console port if the router is broken or we don't know the details to connect to it. So as long as you have physical access to the router, you can connect to it with the console port. As you can see, there's two different options. One is USB and one is RJ45. A USB cable like this one is the newer approach. It connects a device directly to your laptop or computer. It should work out of the box with Windows 10, but if you're going to use another operating system, you may need to get a driver from Cisco to make it work. The other option is a serial cable, like this one. You connect this to the router's RJ45 console port and the other end to your computer. In the olden times, computers had a serial port that you could connect the other end to. In fact, I remember when this was common, which kind of makes me feel pretty old right now. You generally don't see these ports all that often anymore, so you would probably need a USB to serial adapter like this one. And you may need drivers to make that work too. I have always used the serial cable with the adapter. And I still use it mainly because that's what I've always done. It's what I'm familiar with. But the other reason is because some other devices, usually non-Cisco devices, only support serial connections. They don't have that USB port. So it's good to have this adapter available because you can be versatile. In the very old days, terminals like this one were used to connect to mainframes. While we've moved beyond these terminals these days, their text-only style has still hung around. So today, instead of having terminals, we use software called a terminal emulator. You can install a terminal emulator onto your computer and use it to connect to the device. Some of these you need to pay for, some are free, but really any of them should do the job. I'm going to recommend that you start with a free option called Putty. It's free, it's easy, it's popular. Just do a quick Google search and you'll find it, download it, and go from there. Now, before we connect to the router, I'm using a Windows system here, which you'll notice soon. You need to know what COM port you're using. A COM port is how Windows sees a serial port, and depending on your system, there may actually be more than one. On a Windows device, you can find this COM port in the device manager under Ports. Here you can see my USB to serial converter, which is known as COM3. Now we open up Putty, change the connection to serial, and then we change the serial line to COM3. You can see that there are other connection options too, and we'll discuss a few of these a little bit later on. The rest of the settings you can leave as default for now. Just click Open to open the connection. Hit Enter a few times and you are now connected to the router. When you first connect, you'll see that the prompt is the router's name, followed by this symbol. I'm not sure what you call that. Is it a greater than symbol or a right arrow? Whatever you want to call it, what it means is that we're in user exec mode. This mode gives us very limited access and it won't allow us to configure anything. So we need to get ourselves some more access. We do this by typing in the enable command. You'll notice that the symbol at the end of the prompt has changed. The name of this symbol depends on where you're from. You might call it a hash symbol or a pound symbol. Whatever you want to call it, it means that we're now in privileged exec mode, and this gives us full access to the router. Something to keep in mind for later is that we weren't asked for a password. In our case, that's because this is a brand new router, but that's also a bit of a security hole, so we'll need to fix it up a bit later on. When we want to get information from the router, we use show commands. For example, we can see the current time on the router by typing in show clock. Or we can see the software version with show version. If there's too much information to fit on the screen, you'll see the more line at the bottom. You can use space to move through this information page by page, or you can use enter to move through it line by line. What we're going to do is just press Q to quit without seeing everything. And this just takes us back to our regular prompt. If we don't know the exact command we want to run, we can use the question mark symbol. As soon as we press it, the CLI gives us all the available options that we can use. Some of the commands are short, like show clock, but often commands can be several keywords long. See here that we can optionally add the detail keyword to show clock. And have a look at this. If we start typing a keyword and then we press tab, the CLI will figure out what we mean and it will complete it for us. It's a very friendly CLI in that way. Oh, and if you're not familiar with the term CLI, that's command line interface. That's basically what we're seeing here, where you type commands onto this line. There you go. Okay, we can also shorten commands. Sometimes we shorten them too far and we get this ambiguous command message. We do have to give the CLI enough information to work out what we mean, but as long as we do that, short commands are fine. I'm going to try to use the long version of each command in these videos so there's no confusion around what I'm trying to do. Okay, let's actually configure something. We'll start with the router's name. To do any configuration, we need to enter configuration mode. And we do this by typing in configure terminal. Notice that the prompt changes again. The config part shows that we can run configuration commands. And now that we've changed modes, our global exec commands will no longer work. But here's a little trick for you. It's something that not everyone knows, not even people who've been configuring routers for some time. But if you put a do keyword on the front of your command while you're in configuration mode, you can now run global exec commands. And that's a lot faster than jumping in and out of configuration mode, back to global exec, back into configuration. It really saves you some time. So anyway, back to changing the hostname. This is actually pretty easy. We're going to use the hostname command, followed by the name that we want to use. We're going to use internet router. This immediately updates the prompt with the new name. And now that that's done, we can exit configuration mode. We can either type the word exit, or we can use a keyboard shortcut. Most of the time I prefer using a keyboard shortcut, which is Ctrl-Z, and that will take you right back to global exec mode. And when you do that, you get this message on the screen. Messages like these ones are log entries. The router has logged that we've finished the configuration, and has put a timestamp on it, and that's why it's important that the clock is set correctly. And we will see these log entries whenever we're connected to the console port. But let's get back into configuration now, and let's look at configuring an interface. The router I'm connected to is different to the one we saw pictures of earlier. So first we'll have a look at what interfaces we have available to us. We can do this with show IP interface brief. Here we can see we have two interfaces. We can see that one interface has an IP already configured and the other does not. We can also see that both of these interfaces are administratively down. This means that the ports are currently disabled. So let's enable the second interface and we'll give it an IP address. Once we're in configuration mode, we enter into interface configuration mode with interface gigabit 0/1. This changes the prompt again, this time to config-if. So any configuration we use here applies to this specific interface. We'll start by giving it a description. This is technically optional, but I always recommend doing it. I always do it myself because it makes my job easier later on. And now for the IP. We do this with the IP address command. We give it the IP we want and the subnet mask. If you want a refresher on how IP addresses and subnet masks work, click the link to see the video on that. Now remember how the interfaces were administratively down. If an interface is admin down, it means it has been manually disabled. It is shut down. If we want to manually disable an interface ourselves, we would issue the shutdown command. Of course, it makes no difference here, as it's already shut down. Anytime that we want to turn a command off, we simply put the word no in front of it. So, no shutdown removes the shutdown state from that interface. And straight away, we see log messages showing us that the interface has now come up. Right, so we're done with the basic interface configuration. Let's just verify by having a look at the list of interfaces and see that it has an IP, and the status shows that it's up. Next to the status is the protocol column. This also shows that it's up, as the interface is connected to another device. If I unplug the interface, we get a message telling us that the line protocol is down. If you press the up key on the keyboard, you will see the last command that you ran. Let's run this again to see a list of our interfaces. The status now shows us down, but not administratively down. This is because we haven't manually disabled the interface with the shutdown command, we've just unplugged the cable. If we plug it back in, which I'll do now, more messages are logged to tell us that it's back up. Another useful command is show interface description. This gives us a simple list of interfaces and the descriptions that we gave them. This makes it easy to find what each interface does, especially if you have a lot of interfaces. Now, we've been looking at physical interfaces so far, but I'd like to take a moment to show you that you can create virtual interfaces as well. As an example, we're going to create a loopback interface. This is very similar to configuring a normal interface. Enter interface configuration mode with interface loopback 0. The 0 here is just an example. You can pretty much use any number that you want. Now for an IP address, these interfaces are enabled by default, so they come up straight away. And we'll just finish that IP address now. Now we'll look through the interface list one last time. We can press the up key several times to go through our list of recent commands. And look at that, we have a new interface with an IP address. We'll see what loopback interfaces do and why we use them a bit later on as we go through this series. Our goal is to be able to connect to this router over the network. We don't want to use the console cable every time. And configuring the interface was the first part of that. The next thing we should figure out is authentication. If you're not familiar with that term, authentication is just proving to the router that you are who you say you are, and a basic form of that is a username and password. And we use this because we only want authorized people to make changes on the router. We'll start by securing the enable command. You'll remember earlier that we typed in enable and we got full access to the router, and it didn't ask us for a password. That's what we're going to change here. We want the router to ask for a password whenever anyone enters the enable command. In configuration mode, if we look at the enable command, we see we have options to set a password or a secret. You might think that password is what we want, but no, it isn't. The password keyword uses weak encryption, while secret securely encrypts the password. Towards the end of this video, I'm going to show you what I mean by that. It'll become clear a bit later. In addition to this, we want to create an account for each person. That way we don't have to share the password out amongst multiple staff. This is done with the username command. We also add privilege 15. On a Cisco router, privilege 15 means full access. It's kind of like an administrator account on Windows or the root account in Linux. And once again, we add a secret. Now what this has done is it has created a user account on the router itself. So if you have several routers and several switches, you'll need to go to each one and configure the same list of users. You can configure an external server to have a list of all your user accounts, so you don't need to do it on every device, but that's outside of the scope of what we're doing now. We're just starting with the basics. We might get to that some other time in the series, we'll see how we go. Okay, for the next thing, Cisco devices have virtual terminal lines, and we can connect to those with our terminal emulator. These are they're like that console port that we're connected to right now, but they're virtual versions. And we can use those to connect to the router over the network. Anyway, we need to configure these to allow remote logins. It's very much like configuring an interface. So enter in line VTY04. The line VTY part refers to configuring the virtual terminal lines. Routers will have 5 of these, so we give it the range 0 through to 4 so we can configure them all at once. Switches have 16 lines, so that's 0 through to 15. And now that we're in here, we tell the router which protocols we're happy for users to log in with. The common ones you'll see are SSH and Telnet. Both of these protocols use TCP to send terminal information across the network. In this case, PuTTY is the client and the router is the server. So in most cases, we prefer to use SSH instead of Telnet. This is because SSH is encrypted and secure, while Telnet on its own is not. You can allow both if you want, but we're going to stick with just SSH for now. There's only one last thing to do right here, and that's to issue the login local command. This tells the router to look for user accounts locally on the router, that is, like the account we created earlier. If we type exit now, we leave the VTY configuration mode and drop back to regular configuration mode. This is different to when we use the shortcut when we press Ctrl-Z, because the shortcut would take us right back into global exec mode, whereas this just takes us back one level. Now, back to SSH. It is more secure and therefore requires a little bit more work to get going. I won't get into a lot of detail about how SSH works because it can be complicated, so we'll just go through the minimum requirements we need to configure it. Firstly, SSH needs a domain name. We configure this with IP, domain name, and we'll use networkdirection.net. Of course, you can use whatever domain name you want. Next, we configure a key. This is called an RSA key. SSH will use this key to encrypt and decrypt traffic. You do this with crypto key generate RSA. Sorry, that's crypto, then space, and then key. And you can see the full router name that's used when creating the key. The router will also ask us how many bits we want to use for the key, offering 512 as the default value. In my opinion, 512 is far too low by today's standards. I suggest you use 2048. By default, SSH version 1.99 is automatically enabled, but we're going to turn it up to SSH version 2. Now, while we're here, I'd like to introduce you to banners. Banners are useful bits of information that are displayed during login, and we often use them to display legal disclaimers. Here, we're going to configure the login banner. This is shown every time we try to log in, just before we enter our username and password. Banner login is the command we use, which is followed by a character called the delimiter. The delimiter character can be any character, but we're going to use the hash character. We start with the delimiter here, and we're going to put in our banner over a few lines if we want. We're going to type in authorized logins only, and intruders stay out. And then we put that delimiter character again. So everything between those two characters is the banner. Another type of banner is called the message of the day, or MOTD. It's also displayed when accessing the router. It's different to the last banner, as the last one is only shown if the router asks you for login details. Remember before how we weren't asked for login details? The login banner wouldn't show then, but the message of the day banner still would. Now, there are other kinds of banners. There are ones that'll show up after you log in, for example, but I'm not going to bore you with every single type and what they're for, so that's going to be part of your homework. Go have a look, find out what banners there are, how to use them, and why you would use them. Okay, we're finally there. It's time to connect to our router over the network. No console cable required. So, I'm closing PuTTY. I'm reopening it. This time, I'm going to leave SSH selected. You'll see that Telnet's also an option here. I'll enter the IP address that we configured earlier and click open. Notice the banners that we configured? they're showing up as well. And notice that we're being challenged to provide a username and password. And because we use privilege level 15, we don't even need the enable command, we've already got full access. All the configuration that is currently active in the router is called the running config. We can see this configuration with show running-config. People frequently use show run to keep it short. We can see the settings for the interface we configured, as well as lots of default commands. This running config is also the reason we used the secret keyword earlier when creating an account. This is called type 5 encryption, which is a strong form of encryption. A regular password uses type 7 encryption, which is easily broken. If you don't believe me, just Google decrypt type 7 password if you'd like to see what I'm talking about. But why is that important? Well, imagine that we've saved a copy of this running config file here into Notepad, saved it on our computer, and someone else has got a hold of that file somehow. If we're only using those type 7 passwords, they can easily decrypt them, they will know our password to the router, and if we reuse passwords, they might know our password to other things too. Okay, back to the running config. There is a catch. The running config is stored in volatile memory. That means that if the router reboots, we lose all the changes we've made. But don't worry, it's not all over. Don't panic. We can save the running config to non-volatile storage. Did you know that the routers and switches have storage? Just take a look at this. It's not a lot, but this router has some flash memory. And this flash memory is not erased on reboot. When the router starts up, it loads a file called the startup config into memory. Once it's loaded into memory, it is now the running config. So we can reverse that. To save our changes, we need to copy the running config to the startup config. And this is done by typing in copy running config space startup config. And this is often shortened to copy run start. Another way that you can do this is with the command write memory or just wrmem. This command has been around forever, so you're going to see people who are using it. It does the same thing, but some devices don't use this command anymore. I've also heard that on the exams they don't like you using write memory, so get used to the copy run start version. And congratulations, you now have a basic configuration on your router. We'll be adding all sorts of different configuration throughout the series. So, your homework is to try this out in a lab and practice your skills. I'm not going to go into a great amount of detail on how to create a lab because there's plenty of information that other people have put out there, but I'm going to give you a place to get started. So there are a few ways you can do this. The most obvious one is to go out there and buy some hardware, buy a few routers, buy a few switches, get the cables, cable them all up. This may be good if the place you're working for is throwing out some old equipment that they've decommissioned, but most of us would need to look on eBay or somewhere like that. This is kind of an accurate way to lab something out because you get the hands-on experience with actually cabling things through, and you know it's actually going to work on this particular router. But you're limited with this because if you want to try doing something that your router doesn't support, like if you need a bigger router or something like that, you're kind of stuck. And also, it's loud. Routers and switches can be loud. They hum and buzz and things, and they take up physical space in your house, which is not always ideal. So your other option is to create a virtual lab, and this is what I tend to do myself. Virtual is different because you can create a great number of devices. You don't just have to rely on having, say, 2 or 3 routers that you have sitting in your home. You can create 20 virtual routers and cable them all up virtually. The downside to virtual is that not every single physical feature is available in a virtual environment. But for the CCNA level exams and even a few after that, you shouldn't need to worry about it. They can do pretty well everything you need to know. So your first option in the virtual world is Cisco's Packet Tracer. This has limited functionality, but it's really good for seeing how packets are flowing through the network, and it's great to get started. This is where I started, in fact. It's suitable for the CCNA exam, but not so much when you go beyond that. You can get Packet Tracer by signing up to Cisco's Networking Academy, and I presume that costs money. Another very popular option, probably the most popular option, is GNS3. It loads real router and switch operating system images, so you know that what you're seeing here is going to be exactly like it is on the real device. But the downside is, well, how do you get these software images? They don't come with the GNS software because, well, it's difficult to get them legally. It's like downloading Windows. You generally can't just go and do that legally. So you need to have some way of getting those images. However, the GNS software itself, it's free, and you can use some other vendors as well. You don't have to limit yourself to just Cisco. The next option is Viral, which is also made by Cisco. This is the one I use in most of my day-to-day labbing work. It supports real software images, but they come as part of the package, so you don't need to go out and find them. For the most part, this is Cisco only, but there is some support for some Linux servers if you want to see how servers connect into this environment, and you can integrate it into your real network as well, so you can use it to mix a bit of virtual with a bit of physical. The downside though is it comes with a price tag. I think it is $199 US per year. Finally, there's a package called Eve NG. I've never used this one myself, but I've heard some very good things about it. It's vendor neutral, so I'm fairly sure it can run non-Cisco devices. Once again, you have to figure out how to get the images to run on the devices, but I'll leave that up to you. And there are free and paid for options depending on the features you want to run. So, go out there, figure out what you want to do, which lab you want to make, and practice. That's the key to getting a good understanding and the practice to passing an exam, and definitely the practice to getting into the real world. So we're going to try to do some labbing in every video of this series if we can. I hope you've liked this video. Please share some feedback in the comments below if you have any, and if you know someone else who can benefit from this, please share it with them. In the next video, we're going to start by looking into switching and how it works, and I hope to see you there.